Okay, guys. So today we'll be starting with exercise 8B of chapter 7 of logarithms. Chapter 7 of logarithms. And in this video, I'll be doing question number 1 and question number 2. And I'll be solving the respective subparts of exercise 8B. And I have referred all these problems that I'm about to do from class 9 Selina publications. And the book is the subject maths, of course, and it is written by Mr. R.K. Bansal. So all the problems that are mentioned below and that I'm about to do, you could refer from that book. Okay, so without any further delay, let's start. So question number 1 states that express in terms of log 2 and log 3. So our first subpart states log 36. Now what does log 36 mean? So taking the question number 1 statement expressed in terms of log 2 and log 3, they have given you the first subpart log 36. Now what you have to do is that the question is asking you that log 36 represent log 36 in log 2 and log 3. That it is simply referring, it is simply telling you that log 36 should only consist of log 2 and log 3. Log 36 should be represented only log 2 and log 3, no other log numbers, only log 2 and log 3. So log 36 can be written as, so our first step to represent 36 in terms of log 2 and log 3 is that represent 36. So I could represent 36 as 3 square into 2 square. Why? Because 3 square is 9, 2 square is 4, and 9 fours are 36. So therefore log of 36 is equal to log of 3 square into 2 square. Now over here, there are list of laws given over here. So our first law states that log of m into n to the base p is equal to log of m to the base p plus log of n to the base p. So there are certain laws given here. So I would give you a moment to just note this down or take a screenshot, whatever. So once you have finished the screenshot, I will be using the first law to solve log 3 square into 2 square. So log 3 square into 2 square, I could write it as log of 3 square plus log of 2 square. Now, in my previous video, I had mentioned that if there is no base given, so I could assume it as 10. So here there is no base given, so I could assume it as 10. Also, there is no base given here or mentioned here, so I'll assume it as 10. Now over here in the list of remember laws, in the third law, it states that log of m n, now m here is the constant and n is the power here. So log of mn to the base a is equal to n log of m to the base a. So we'll be using this third law to solve our first subpart of question number 1. So I could write this as 2 log of 3 to the base 10 plus I could write this as 2 log of 2 to the base 10. So this is how I'll represent log 36 in terms of log 2 and log 3. So I hope you guys understood this subpart. If you didn't understand it well, I would advise you that you would go through this, rewind the video a bit, look at all the facts and steps I've mentioned, and then you'll be good to go. Moving on to the next subpart, log 144. Again, you have to represent log 144 in terms of log 2 and log 3. So I'll represent log 144 as 12 into 12. Now 12 into 12 can be written as 4 into 3, and that can be read. So simply 144 can be written as, so simply I could write 144 as 2 raised to the power 4 into 3 raised to the power 2, because 2 raised to the power 4 is 16, 3 raised to the power 2 is 9, and 16 into 9 is 144. So log of 144 can be written as this. And using the first law over here, log of m into n to the base p is equal to log of m to the base p plus log of n to the base p. So I could write this as, now again, there is no base mentioned here, so I'll write 10 just in case. And with the help of the first law, I can write this as log of 2 raised to the power 4 to the base 10 plus log of 3 square to the base 10. Now in the next step, I'll be using the third law, which is log of m raised to the power n to the base a can be written as n log of m to the base a. So therefore, log of 2 raised to the power 4 to the base 10 can be written as 4 log of 2 to the base 10. And I'll be using the same method to solve log of 3 square to the base 10. So I could write this as 2 log of 3 to the base 10. So this will be your final representation of log 144 in terms of 2 and 3, log of 2 and 3. Moving on to the next third subpart of question number 1, exercise 8a. Now over here, log 4.5. So log of anything. It could be log of anything. Log of fraction, log of simple number, log of whole number, log of decimal. It could be anything. Don't be surprised. As it is said over here in fraction. Now over here, I'll just change the color to yellow. Okay. So now log of 4.5, you have to represent it in log 2 and log 3. Don't be panicked. If you think that this is not possible, 4.5 cannot be written in terms of log 2 and log 3, you are thinking wrong. It can actually be log 2 and log 3 only and only if you can solve it with the same method that I solved the second subpart and the first subpart. Now log 4.5, all you have to do is you have to write 4.5 in terms of log 2 and log 3, in terms of 2 and 3. So log of 4.5 can be written as log of. Now over here, there is a slight change. I had mentioned that I could write 4.5 in the terms of 2 and 3, but I can simply write 4.5 as 45 upon 10. And furthermore, it can be divisible by 5. So 9 5s are 45 and 2 5s are 10. So our final answer to 4.5 will be 9 upon 2. Now in the second law, over here, it is mentioned that log of m divided by n to the base p is equal to log of m to the base p minus log of n to the base p. In the first sum, it was log of m into n. In the second law, in the first law, it is log of m into n. In the second law, it is log of m divided by n. And therefore, in the first law, there is an addition symbol, and in the second law, there is a subtraction symbol. Now over here, it is 9 divided by 2. So we'll be taking the second law. So over here, log of 9 by 2 can be written as log of 9 minus log of 2. Now log of 2, we have gotten log of 2. Now all you have to do is you have to mention 9 in terms of 3. Now in terms of 3, 9 can be written as 3 square. Log of 3 square minus log of 2. So therefore, taking the third law, log of m to the power n to the base a can be written as n log of m to the base a. So therefore, I could write this as 2 log of 3 to the base 10. Because there's no symbol mentioned here, so we'll take it as 10. Minus log 2, we leave it as it is, log of 2 to the base 10. So this is the final representation of log 4.5. See, I told you, if you will solve, if you have the power, if you have the courage to solve this, any sum, you will get it. You'll get the reward. So moving on to the fourth subpart. Now over here, log of 26 upon 51 minus log of 91 upon 119. Now what do we do? This is a big monster. What do we do? So all we have to do is we will take the second law. Second law, this is the second law. So we'll be taking the second law and then we'll be solving the fourth subpart. Taking the second law, I'll just rub this. So taking the second law, I could write this as log of bracket 26 divided by 51 whole divided by 91 91 by 190 brackets. Then furthermore, I could write this as log of 26 divided by 51 into, I could write this as into 119 divided by 91. So this is how I would write it after this equation here. And then it would be divided by, then we will start dividing it by each other. So 51 threes are 17 threes are 51, 17 sevens are 119, and 26 13 twos are 26, and 13 sevens are 91, and therefore the 7 and 7 gets cut. So we are left with log of 2 by 3, and log of 2 by 3 can be referred as log of 2, taking the second law mentioned over here again. So we could write this as log of 2 minus log of 3, and we'll use a base as 10 because there's no base given, so we'll assume it as 10. So this is the final representation, how we represent log of 26 upon 51 and log of minus log of 91 upon 119. This is the final answer of the fourth subpart. We'll move on to the fifth subpart. So in the fifth subpart, there is even a greater. There is the, in Hindi we known as the BAP. So this is the BAP of the fourth sum. So we'll try to solve it, don't worry. So over here, what we'll do is, we'll first solve this part. Now over here in the rest of the values, log of 75 upon 61 and log of 32 upon 243 doesn't cause much of a difference. But over here it is mentioned 2 log 5 upon 9. So 2 log 5 upon 9, I could write it as minus log of 5 upon 9 whole square according to the third law. So the third law is mentioned over here. Plus log of 32 divided by 243. So I could simply write this as log of 75 upon 16 minus log of 25 by 81 plus log of 32 by 243. Furthermore, I could write this whole equation given here as, so what I've done here, I've gotten all of these monsters in one big roof. So what I've done is log 75 upon 16 minus log of 25 upon 81. According to the second law, I have written it as 75 by 61 divided by 25 by 81, which is 75 by 61 into reciprocal of 25 by 81, which is 81 by 25. And over here, plus log of 32 upon 243. According to the first law, this will be equal to 81 by 25 into 32 by 243. So there's no need to take a reciprocal. So over here, I can simply write this as 16 2s are 32, 25 3s are 75, 3 81s are 243, and 81 81s are 81 ones are 81. So all we left is 2. So therefore, the simple answer to all of this big monster, the heart, the core of the big monster is log of 2. So the representation of this whole monster is log 2. So I hope you guys understood this part. I would request you to go rewind the video a bit and go through this video again. So let's move on forward to our question number 2 of exercise 8b. Express in the form free from log. Now free from log means that you have to, so I'll just show you. So I'll show you a demo, don't worry. So 2 log x minus log y is equal to 1. Now 2 log x, I could write this as log of x square according to the third law, minus log of y is equal to 1. So therefore, according to the third law, according to the second law, in fact, log of x square will be divided by y, which will be equal to 1. And as I've said before, that if there is no base mentioned, I could assume it as 10. So therefore, this is the logarithmic form, and I will denote it down in the form of exponential form. So 10 raised to the power 1 is equal to x square upon y square. So therefore, this can be written as 10y square is equal to x square, because the y square that is divided by x square in the RHS will move to the LHS and get multiplied by 10, and it will give you 10y square is equal to x square. Now in this answer that we have gotten, this is the answer to the first subpart, and over here this exponential form is free from log form. That is what I'm telling. In all of these subparts that is given in question number 2, you have to arrange the subparts in such a way that it is completely free from the log form. So over here you have to simply arrange it in exponential form, simply saying, in a nutshell. Now over here, same, there is this log form, you have to convert it into exponential form. or simply you have to free it from its log bonds, log chains. So log 2 log x, I can write it as log of x square plus log of y cube is equal to log of a. According to the first law, I could write it as log of x square into y cube is equal to log of a. So therefore, log x square y cube is equal to log of a. And over here, log and log are equal, so they'll get cut. So finally, x square y cube will be equal to a. X square y cube is equal to a. Now over here, we have denoted the final answer of this log monster in the simple exponential form. So this is the second subpart. I have freed it from its chains of log form. Moving on to the third subpart. So our third subpart states that a log x minus b log y is equal to 2 log 3. So you have to represent it in exponential form, completely free from the chains of log form. So I could write this as log of x is by a, this is a, not 9. So I'll just write this clearly. Log of y raised to power b is equal to log of 3 square, which is 9. So over here, according to the third law, I could write this as, according to the second law, in fact. So I could write this as log of x raised to power a upon, I make this mistake, I make this habit of writing a in the form of 9, divided by y raised to power b is equal to log of 9. So over here, log is equal, so it will get cut. And finally, x raised to power a, y raised to power b is equal to 9. So therefore, x raised to power a is equal to 9 y raised to power b. So over here, I've represented this whole log monster in such a way that it is completely free from the chains of logarithm. And there was only one way to do it. I had represented in an exponential form, which brings us to the end of this video. I hope you guys enjoyed this video. So I would request you to that if you haven't understood anything that I have mentioned in this video, you could just rewind the whole video and look at it again, and I'm sure you'll understand it all. Secondly, a note to the viewers that my channel partner has made a video, Logarithm Made Easy. So you'll find everything you need to know about logarithm, all the laws, all the facts in that video. So I recommend you see that video, then come to this playlist of logarithm. So I hope you guys enjoyed this video. So take care and bye.